told you that after adsorption I should have taken heterogeneous catalysis, but I don't know how I missed it. So I started with colloids. Now you know about colloids, that what type of substance colloid. So it is not that colloid is a specific type of substance. Huh? It is a state of substance. See, any substance which acquire that shape, then we call them as colloid. Then we have discussed about the classification of colloids. We classified them in three categories based on their physical state and their interactions with the dispersion medium, and uh,
Sir,
how the colloids are formed. Yes.
sir, can't hear you, sir. Could you speak loudly, sir?
Hel- Hello.
Sir, could you speak loudly, sir? I can't hear you, sir.
Acha. Now, just telling about what are the things that you have done till now. So, we have done. We have discussed about the colloids. We discussed about its classification and classification based on their physical state. We then on their interactions with the dispersion medium, and also how the colloids formation has taken place. We have found that to attain colloidal size, there are three possible ways. One, the molecule should be big. So we have found most of the polymers are colloids. Second, we find there are some tiny particles, especially metal atoms. They're individually not stable, so they come together and form a cluster by which generally they are inseparable, and in that case they acquire a larger aggregated mass, that is then has uh, by which they get the dimension of colloid. And we have found there are some particles are there who are extremely stable and generally act as a solute, form true solutions. But if they are added in large amount, then they associate themselves and acquire a larger size. Okay. Then after that, we have found different ways of making colloids. We have found we have physical methods of making colloids. We can have chemical methods of making colloids that we have discussed. Then we have found that another method is there by which you can convert a precipitate or a suspension, you can say, precipitate into colloids, and that process is called peptidization, where you can convert a freshly precipitated substance into colloids. Why they go to the colloidal state? We have found those freshly precipitated substance absorb some specific cation or anion, by which they develop a repulsion within themselves and disperse into the colloidal. So that we have discussed. After that, we have gone for the physical properties of colloids. We have discussed about its colligative properties. We have found as the colloidal particles remain in group. So the number of the free groups are less if you compare with that of the particles, and because of that, the its colligative properties are less, because colligative properties only count the number of particles present, whether they are together or alone, they do not bother. In true solutions, all of them they remain in the individual form, so the number of particles are more. In colloids, they remain in group, so the number of particles decreases. Because of that, the colloidal particle properties decreases. Okay. Then we have found uh, that about its optical nature. We have found if you pass a strong beam of light through the colloids, then you find that it glitters or dazzles. Is because the colloidal particles scatter the incident light, and they are found to be visible. And they appear in a cone shaped, and that is called Tyndall cone. and the phenomenon is known as tingling. Then we talked about the Brownian movement. Okay, we found that colloidal particles continuously move in a zigzag fashion and even without a rest in when they are present in dispersion medium. And we have found that the reason we have found that dispersion medium particles collide with the colloidal particles, and because of that, of the unbalanced force, so they keep on moving. All right. Okay. Then we have this discussed. Then we have discussed about its. Then we have discussed about the charge on the colloids. Oh, sorry, before that I like to charge on the colloids. We have found that specifically with the lipophobic colloids, as they are unstable, they like to precipitate. So they are being stabilized by the charges. All the colloidal particles of the same colloid, they have the same charge. As because they have the same charge, the charge is being induced by adsorption. Okay, induced by adsorption, and because of similar charges, they repel from each other and they become stable. On the basis of that, you can have positively charged colloids and you have negatively charged colloids. Okay, so positively and negatively charged colloids are there, and all the you have seen in your book also the colloids are classified on the basis of their charges. Okay, but in your laboratory you can make your own colloid according to the charges that you wish by selective adsorption of the ions on them, and only the technique is different. So yesterday, last class I showed you that if you have made ferric hydroxide colloid by treating ferric chloride with hot water, you get ferric hydroxide, and to that if you add few drops of ferric chloride, ferric ion get adsorbed and it becomes a positively charged colloids. But instead of that, if you have reacted ferric chloride with sodium hydroxide, then you get ferric hydroxide and sodium chloride. And after that, if you add little bit more of sodium hydroxide, the hydroxide ion get adsorbed on the ferric hydroxide, and you by that way you can make the negatively charged ferric hydroxide. Same in your book, this example is not being given. In your book, the other example is given about the silver iodide colloids. In that case, you find that if you have a large excess of silver nitrate into potassium iodide, after the formation of silver iodide, silver ion get adsorbed, so you get positively charged colloids. And if you do the reverse, you take silver nitrate and do that, if you add excess amount of potassium iodide, in that case you find to the silver iodide ion is absorbed, and by that way you can get negatively charged silver iodide colloids. Then I told you, I have shown you the state of colloid. The adsorbed ion remain fixed on the surface of the colloid. So it is a fixed layer, and as because all colloids are electrically neutral, so the oppositely charged ions, they hang around them. They keep on moving like cloud. Hmm? So this is a mobile layer. So you have a fixed layer and mobile layer. The electrical differences between them, the electrical potential difference that is between them is called zeta potential or electromagnetic potential. So this much we have done. Now we come to a very important point, is the precipitation of colloid. We made the colloid, now to precipitate it. Precipitation of colloid is called coagulation. Okay, coagulation. This is the precipitation of colloid, and as they keep on floating, most of the colloids they float. So because of that, somehow it is not even given in the book. It is also called flocculation. Okay, so it is precipitation or flocculation. So precipitation of a colloid is called coagulation or precipitation. Now, I told you how the colloid particles they remain, say this colloid C, okay, and they remain uh, away from each other because of the repulsion between them. If you want that they should precipitate, then all of them should come together. Then they become heavy. Then they then they precipitate. Okay, it may happen here that it may be all negatively charged. So if you want to precipitate them, so in that case, this colloid positively charged colloids had to get rid of their positive charges and they should get rid of the negative charges. So only then you'll precipitate. So there are several techniques. Okay, some of the techniques you have already done it at home. Okay, so let me write it by boiling. See, if you boil the colloids, you are supplying so much amount of temperature to the colloidal particles. And these are charges means what? All the charges are being carried by some metal or non-metal ions. These are being charged with, here let me write here ferric ion. You have ferric ion. So when you heat it, the heat is being supplied to them. And when it's being heated, being supplied, the kinetic energy of both of them increases. And by that way, the ferric ion get dissolved. It could overcome the attraction of the ferric hydroxide and it can be expelled. So it will go. So that way what will happen? All the charged particles, they move away from each other. Similarly, the negatively charged colloids also will move. So on that basis, they will come together and they will precipitate. Okay. Now a simple example which you have done at home or is being done in your kitchen, you did not see the change, but you have seen the change after that. It is nothing but the boiling of eggs. See, when you boil egg consists of two parts. One is your center. At the center, you have yellow one that you call it yolk. And other than that, you have a colorless part, fluid. Okay, that is a colloid. I told you that colloid is made up of protein. When you heat the egg, what happens? Is it that part becomes solid? Huh? Then we call it white of an egg only. How it has happened? Because the protein which was present there, it was carrying some charges. So by heating, all the charges got dislodged and they have precipitated in the form of and become solidified. Okay. Now let me go to this example, negative charge. See, you will find generally in Shillong, the municipal water which is being supplied to us, these are, especially during summer, is not that clean. You keep it is muddy. This is a very interesting thing. I think is only exists in entire India is the Shillong municipal water. Other places municipal water are perfectly clean. Here it is not like this. It contains mud. So it is not healthy for us to drink this water. And muddy water is a negatively charged colloid. So when you boil it, what happens? After boiling, you will find all of them, they settle down and the water become clean. So this is the way we precipitate the colloids. So this is by boiling. Second one is the repeated dialysis. See, dialysis is a process to remove the impurities or ions present in the solution. So once you do the dialysis, what happens? The free ions which are present there in the solution, they go out. But if you do the repeated dialysis, what happens? The ions which are clinging or adsorbed on the surface of the colloid, they gradually also go out. When these adsorbed ions also go out of the colloids, they leave the surface of the colloids, then they come together and precipitate. By repeated dialysis also, you can remove the third method. Okay. Now here we have used some physics. This is the physical process of precipitations. Now we want to go for adopt some chemical process. So what is the chemical process? Because you know, if it is a positively charged colloid, if I supply some negative ions, then it will go and neutralize the positive charge which is adsorbed there. So that can be done. Okay. So now we'll go for the reaction. What we'll write now here? By the reaction between oppositely charged all right. So let me take this is a very famous example. This is a positively charged colloid, and this also I have shown you. We have prepared it. Arsenic sulfide. Arsenic sulfide. We have prepared. Remember, we have prepared arsenic sulfide salt by passing. We have taken arsenic oxide suspension, and through that we have bubbled H2S gas. H2S has reacted with the arsenic oxide to give you arsenic sulfide colloid. But if you pass H2S, H2S breaks down to give you 2H plus and H2 minus. So that's minus. That's okay. So this is positively charged colloid and this is negatively charged colloid. When you mix them in this way, it may undergo partial coagulation or complete coagulation depending upon the stoichiometric ratio that you have used. So what is going to happen? See here, S2 minus will react with Fe3 plus. So by that way, what is going to happen? This will get rid of this one. Sulfide also will come out from this. And you are going to get here. This is generally being commonly asked in the exam. Okay. One method I already told you. What is that method? Please remember. I call it electrophoresis. Last class I told you electrophoresis. What happened? Electrophoresis is nothing but the electrolysis of colloids. So when you do the electrolysis of colloids, the charged colloid will go to the oppositely charged electrode. Either it will lose electron or it will gain electron. When it will lose electron, suppose in the case of say this, if you have put this one, then this is anion, it will go to anode. When it goes to anode, 2 electrons for the sulfur will go out and it will precipitate as arsenic sulfide and sulfur. If you use this one as a colloid, because along with the how did you prepare? We have prepared with ferric chloride. So 3Cl minus is already there, I told you. Because the anions, in this case, the 3Cl are the floating phases. Keeps on floating. So 3 chloride will go to the anode. It will deposit electron and electron. I have shown you that the electron will come back to the iron and will precipitate as iron. So by electrophoresis also we can very easily we can coagulate any type of colloids. And the last one is important. by addition of electrolyte. See, remember the definition of peptidation. Peptidation, what does it say? It says conversion of freshly precipitated substance into colloidal state by addition of small amount of electrolyte. If you add small amount of electrolyte, ion is absorbed. But if you have added excess amount of the electrolyte, in that case, what will happen? The charge will be neutralized. This charge will be neutralized. So these charges, as they get neutralized, in that case, what is going to happen? It is going to coagulate. So let me read the muddy water. Shillong people, they do not have so much of use of this one. Muddy water we use, but we do not know how to purify it. To muddy water, if you use alarm, I don't know whether you know the formula of alarm. See, it is a negatively charged current. Negative. Alarm will give you what? It will give you 2 potassium ion, then 2 aluminum ion, and 4 sulfate ion, and along with 24 molecules. Water is already there, so I need not write this. So this is the one. This is a double salt. See here. This aluminum ion and potassium ion is going to neutralize the negative charge of the color muddy water, and it will become, it will undergo coagulation, and the water will be purified. See, suppose you want to purify your drinking water, so you may take 5 liter, 6 liter, 10 liter, you can boil it. But suppose you require huge amount of water for your washing purpose. If the water is very muddy, if you wash your clothes with that water, in that case your water also will get spoiled. So how to purify this one? No problem. Alarm is available in the market, even Shillong market also. You go in green grocery shop, they will give you. You crush it into powder and tie it in a, put it in a small cloth and tie it. Okay, the long rope. Suppose it is a water tank, you dip it in the water tank. Keep it for half an hour. Then after that, take it out. You'll find water has become crystal clear and all the mud has settled at the bottom. So you can use the water on the top. Later on, you can throw that mud precipitate which is settled at the bottom. So this is being done. But there is a theory there. Okay? This theory is important for us. This theory is called let me see the spelling. It's called hardest result. Okay? In your book, it is not being given properly. There are 2 parts are there. Good. The ions carrying charge opposite to that of that on colloidal particles are effective in causing the coagulation. This is the first one. Coagulation of the salt. I told you we do not call solution, we call it salt. These are called flocculating This is the first one. That is the second. The coagulating power of an electrolyte is directly proportional to the fourth power of their valency means charge. Valency of the tip is write down. I don't know why in your CBSE book this is not rule. They mentioned hard disclosure rule, but they have not mentioned the law. It's very strange. ನಾನು লিখছি পুনের ফর্মটা আমি এক্সপেক্ট করছি আমি অ্যাপ্লাই করিনি দুটো কোম্পানিতে ব্যাঙ্গালোরটা ব্যাঙ্গালোরটা ভালো ভেরি গুড অমনিকম গ্রুপ থেকে আমি রিক্রুট করেছি ওদের সাথে কথা বলেছে আমার একজন কলিগ তো ফোন করে অমনিকম আমি নিজেই জানি ভেরি ওল্ড এজেন্সি যেরকম এজেন্ট টপ এজেন্সি এরকম পাবলিসিস্ট ডেন্সো সফটওয়্যারটি অমনিকম জাস্ট গ্রুপে ওটার পরে জাস্ট নট আ ব্যাড ঠিক আছে চেষ্টা চালিয়ে যাও মন খারাপ করবে না এত ডিপ্রেশন ভালো না মানুষ তখন চিন্তা শক্তি হারিয়ে দিল Hey, हो गया? Hey, why do you keep silent? अच्छा. So this is the law. Now see application. Suppose you want to coagulation. You want to coagulate a positively charged colloid. For coagulation of positively charged colloid. It can be any colloid. So for precipitation of the positively charged colloid, what type of ion should use? You reply. Don't keep quiet. What type of colloid you should use for positively charged coagulation of positively charged colloid? Are you all sleeping? Huh? Who is going to reply? For precipitation of positively charged colloid, what type of ion should we use? What should be the charge on the ion? What happened? Can you hear me?
Sir,
Huh? What type of ion should I use? Positive or negative?
negative.
Negative. What about others? Why others are do not reply? In that case, I'll stop the tuition. I'm telling you. So negative ion. What does it say? Directly proportional to the fourth power means to the power 4. So I have fluoride. It has one negative charge. I have sulfate. It has two negative charge. Then I have phosphate. It has three negative charge. And another ion is there which is having four negative charge, is called ferrocyanide. See, so in that case, it will be to the power 4. If you to the power 4 means what? It will be 8 times. It will be 4 times, 8 times, 12 times, and this will be 4 into 4, 16 times. So this will be the way you have to select. So this is the best reagent to precipitate a positively charged colloid. All right. Now, for coagulation of negatively charged colloid, so we have to use positive ions. So positive ions I can have here Na plus, then I have Ba2 plus, and I have Al3. So this will be to the power 4 means 4 times, 8 times, and this is 12 times. So this is this. See, I told you when you go for the coagulation of muddy water is a negatively charged colloid. So there we are using the potash alarm, which is having aluminum ion. So you should know. And hard issue rule is important for your exam. And I'm telling you, again, I'm telling you, when I ask you any question, it is not that only one person has to reply. If I find others are not giving any reply or say yes or no or any question, I'm going to stop this tuition from next month. Finish. Take it as an ultimatum, I'm telling you. You are not watching a movie. I'm very serious about it. Do not hide behind your mobile. See, we know that lipophobic salts are highly unstable. So moment it comes in contact with the any type of ions, they try to precipitate. Then how to protect a lyophilic salts? So lipophobic salts are protected by coating with them with lyophilic salts. We prepare the lyophilic salts, and to that we add lyophilic salts, because many of the lyophilic salts do not carry any charge, because most of the lyophilic salts are made of polymers. They do not carry any charge. So in that case, we add lyophilic salt. Lyophilic salts cover the lyophilic salt from outside and does not allow the ions to reach up to the colloid. This is called protection of colloids or protection of lyophilic salts. Okay. Now we'll go for emulsions. So what is emulsion? Emulsion, it is a colloid. It is a colloid where both dispersed phase and dispersion medium is are classification. It is well in water. We write O. And second one is water in. First one is the dispersed phase. That is, if you have taken water and to that, I told you that day that you can take water in a bottle and add few drops of oil there. In that case, if you shake it, you will get this type of oil. Okay, this type of thing as there. And second one is, what is the example of this one? Is milk. In milk, you have fat, which is oily in nature, and you have excess of water. So that is the example of milk. Or the cream which you use during summer. Okay, in that case, the face cream that you use in summer, that also belongs to oil in water, because there the fatty part is added less and we have more water. So immediately dry, so that your face does not look well. Now, water in well. Here, the well is more, water is less. So this type of thing that you use in your winter, cold cream, right? It's like this one. Or these are the different types of the cosmetics that you are using. So this I told you, please read these. That day also I told you to read the applications of adsorptions. So the applications of colloids also you please read from your book. Okay. I thought of continuing in the class, but somehow I'm today because all these days, whenever I ask you any question, I find that you people never reply. Once I told you that I'm not going to teach you, then all of you told me, sir, don't do like this. But I found there is no change in you. So today I'll not finish. Do as you like. If you do not take part in actively in my class, no point of having a class. I don't want to earn any money later. And second thing I told you, all the month, every month I cannot remind you. Many of you did not even pay the fees of June. What is this? Am I a beggar? That I should send you note? Repeatedly I told you it's very, very embarrassing to talk to you about the fees. Today I'll not take. Next day I'll take and finish your I'll take heterogeneous catalyst, and after that you decide whether you want to study or not. If you want to study with me, in that case, you have to be very, very responsive in my class. It is not that I'm teaching someone who is not interested to sit in my class. Do whatever you like. Bye. It's very ridiculous. I have to shout at you that and then only one someone is there only replies others. Only I have found the person who is replying me is Gitanjali.